Hi everyone, welcome back to another math lesson. If you missed out on our video about prime factorization, I'm sharing it in the description box below. Make sure to watch that before you watch this video so that you don't have any trouble understanding this one. What we are going to learn today is one of the most common methods used in schools to calculate HCF, GCF, or GCD, whatever you like to call it. So let's get started. Let's find the HCF of 24 and 36 again, the same numbers we did in the last video, but this time using the prime factorization method. So the first step is to write 24 and 36 side by side and a comma in between them. Make the same lines we did for prime factorization. So start dividing with the smallest prime numbers that can divide both the number 24 and 36. Since 24 and 36 are both even, we can divide them by 2. So let's do that. 24 divided by 2 is 12, and 36 divided by 2 is 18. Now let's check it again. Can both 12 and 18 still be divided by 2? Yes, they can. So 12 divided by 2 is 6, and 18 divided by 2 is 9. Now, take a look at 6 and 9. Can both of these numbers be divided by 2? Not really. 6 can, but 9 can't. So we move to the next prime number, which is 3. Can both 6 and 9 be divided by 3? Yes, they can. So we're going to divide them by 3. Remember, in HCF, GCF, or GCD, you have to make sure that both the numbers can be divided by the prime factor that you're using. So 6 divided by 3 is 2, and 9 divided by 3 is 3. At this point, 2 and 3 cannot be divided by the same prime number anymore. So we stop right there. This is the first step that you need to take. After that, to find the HCF, you have to multiply all the prime numbers that you've written on the left over here. In this case, those numbers are 2, 2, and 3. So what we're going to do, we are going to write that the HCF of 24 and 36 is 2 times 2 times 3, which equals to 12. See how clean that was? Instead of writing big lists or separate factor trees, we just divided both numbers side by side until no more common prime numbers were left. Moving on to the next example. This time we have to find the HCF of 30 and 45. So let's do the same thing again. Write 30 and 45 side by side just like we did before and make the same lines. Start by dividing the smallest prime number that works for both. Can both be divided by 2? 30 can because it's even, but 45 isn't, so we can't really divide them by 2. Let's move on to the next prime number, which is 3. Both 30 and 45 can be divided by the number 3. 30 divided by 3 is 10, and 45 divided by 3 is 15. Now, can both 10 and 15 be divided by 3 again? Not this time, because even though 15 can be divided by 3, 10 can't. How about the next prime number, which is 5? Yeah, both these numbers can be divided by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. Now you'll notice that 2 and 3 cannot be divided by the same prime number anymore. So we stop right there. Again, take all the numbers that you've written on the left and multiply them. In this case, we're going to write that the HCF of 30 and 45 is equal to 3 times 5, which equals to 15. And there's your answer. Okay, enough with the small numbers. Tests and quizzes aren't always going to have two-digit numbers. Let's start with a bigger example. Finding the HCF of the number 120 and 168. So let's try solving this by prime factorization. We'll write 120 and 168 and leave space on the left for our prime numbers. Make the lines like we always do. Start by dividing by the smallest prime number, which is 2. Since both numbers are even, we can divide them by 2. 120 divided by 2 is 60. 168 divided by 2 is 84. Now we have 60 and 84. Can they be divided by 2 again? Yes, they can. 60 divided by 2 is 30, and 84 divided by 2 is 42. Since we have both even numbers again, let's keep going on with 2. 30 divided by 2 is 15, and 42 divided by 2 is 21. Now, can we divide 15 and 21 by 2? No, we can't, because they're not even. Let's move on to the next prime number, which is 3. 15 divided by 3 is 5, and 21 divided by 3 is 7. So write 3 on the left and the 5 and 7 on the inside. Can 5 and 7 be divided by the same prime number again? No, because they're both prime numbers themselves. So we stop here. Multiply all the numbers we wrote on the left to find the HCF. So what are we going to write? We're going to write that the HCF of 120 and 168 is equal to 2 times 2 times 2 times 3, which is equal to 24. And that's our answer. 24 is the HCF of 120 and 168. Okay, now let's make things even more interesting. But this is the last one, I swear. Let's find the HCF of 3 numbers at the same time: 56, 42, and 98. We'll write 56, 42, and 98 and make the lines like we always do. If you've noticed, all 3 numbers are even. So we're lucky right now, and we can divide all of them by the number 2. 56 divided by 2 is 28. 42 divided by 2 is 21. And 98 divided by 2 is 49. Now, can the numbers 28, 21, and 49 all be divided by 2? Of course not, because 21 and 49 both are odd. So we move on to the next prime number, which is 3. If you use the divisibility rules or try dividing them, you'll find out that both 28 and 49 are not divisible by 3. So we skip 3. Remember, all 3 numbers need to be divided by the same prime number. Similarly, we can't divide any of these 3 by the number 5. So how about 7? Yeah, 7 works. 28 divided by 7 is 4. 21 divided by 7 is 3. 49 divided by 7 is 7. Now we can't divide any further since they don't share any common prime factor anymore. So we stop right here. The next step is to multiply the prime numbers we wrote on the left. So the HCF of 56, 42, and 98 is equal to 2 times 7, which is equal to 14. And there you have it. HCF has never been easier. I hope you feel the same way too by now. Want to put yourself to the test? Try finding the HCF of 90, 150, and 210 using the same method. And share your answer in the comments. I would love to see your answers. And remember, if you have any questions, don't hesitate to ask. If this video helped you understand how to calculate HCF, don't forget to like, share, and subscribe to the channel for more math lessons. Don't hate math, keep practicing, and I'll see you in the next class. Bye!